So solving by trial and error, you do this when the coefficient of x squared is not equal to 1. Usually you don't see a number in front of the x squared, and that's because the coefficient is 1. So if it's not 1, i.e. it's 2, 3, 4, 5 or any other number, then you've got to start solving or factorising by trial and error. But the thing that doesn't change is a times b, and by a and b I mean these numbers over here, the a and the b, still have to multiply to give 2. Now that's a huge advantage if there is only one factor of 2, which there is, only 2 times 1. So has to be, has to be 2 and 1. But the trial and error part comes in where I need to know that there are when you expand, that you end up with 7x. So to get 3x squared, again there's only one set of factors for 3, so I can write 3x here and x here. When you multiply 3x by x, you get 3x squared. That works. That works. But you have to check. Okay, I can't emphasize this enough. You have to go and check the full expansion. 3x times 1 is 3x, and 2 times x is 2x. Now that makes a total of only 5x. Okay, if you add 3x plus the 2x, you only get 5x, which is not 7x. So I must have something run the wrong way. I can either swap. I quite like to leave the 3 in the front here, but I do need to swap the 2 and the 1. Notice when I do that, it's 3 times 2, which gives 6x, and 1 times x, which gives 1x, and 6 plus 1 does give me the 7x. And these, in this case, they both happen to be positive. So that's what you're doing. It's factorising by trial and error. Another problem. This one here. Remember, a times b must equal 9. There are two options here. 3 3s or 1 times 9. They will both give you 9. So, but there are also two options for the factors of 4. You could either have 2x multiplied by 2x in the front of the bracket, or 4x multiplied by 1x in the front of the bracket. I'm going to start with splitting it, having 2x in the front and 2x in the front. And in the other end of the bracket, I can either have 3 3, let's write it in, 3 3, or I could have 1 9. Checking, 3 times 2 is 6, and 3 times 2 is 6, 6 and 6 are 12. Hey, I happened to guess it right first time, and that I wasn't actually purposefully thinking about it. I was just putting in numbers, and I happened to get it right first time. Okay, you have to do those checks. 2 times 3 gives 3x, 3 times 2 gives, 2 times 3 gives 6x, and 3 times 2x gives 6x. Add them together, and you do get 12x. Check the 3 times the 3, that gives 9, and 2x multiplied by 2x, that gives my 4x squared. Last example. is this one here. Now, I put this one in here on purpose because there is a shortcut in solving this one. The first thing you should really always do when you've got a coefficient greater than 1 is see if the terms are divisible by that multiple. In this case, 3 goes into 3, it goes into 15, and it also goes into 18. So the first step with this one is to take 3 outside a bracket and I've simplified the problem a whole lot by just realizing that 3 is a common factor of each of those terms. Remember, it just 3 multiplies by each of the terms inside the bracket, and I'm back to where I started. So the answer to this problem okay, we've got a coefficient of 1 for x squared, so x's can go in the front. Multiples of 6, what are they? Okay, and we want to choose a pair that add to 5. Everything's positive here, so I don't need to think about, do I need to put a negative on both of them or on one of them? It works.